Hi everyone, this is Cloud Dragon Podcast, and today I'm going to show you how to properly handle risks in application development. And the reason I want to talk about this is because I constantly see people just doing it completely wrong. Like they overthink the problems, they try to think about server failures, database failures, come up with crazy protocols, over provision stuff, and then they have a stupid outage for like hours because of the simplest possible mistake, like expired SSL certificate or unpaid domain, that just humiliates the whole team and causes a lot of service disruption. I mean, and the server actually never fails. Only SSL certificate expires. So, I mean, there is a lot of bias in all these developers thinking about risk and what could go wrong and trying to adapt to that kind of situation. That's why I wanted to talk about this subject, because I see that there is a lot of hypocrisy out there between developers related to making the best possible solution, because a lot of thinking that a lot of thinking that out there is biased, because we developers, we focus on a small solution, on a certain set of risk we want to manage and want to mitigate, like server failures, database inconsistencies, things like that. But the actual sea of risks is huge. Like there are so many more risks we should probably handle, but we don't, because we don't. First of all, we don't consider those risks, and second, just because we like to focus on a more technical things, like the ones that are popular in blogs, the ones that you could actually report somewhere, the ones that actually sound important, But all these petty risks which are, on a paper equally important, we don't consider them because basically they're not interesting to most of the developers. And this is just one example of a cognitive bias related to risk management. I mean, the way we could screw up the risk calculation is incredible. We could forget about something. We could be biased about something. We could be influenced by so many factors. It's just crazy how how say not how the thinking of our brain is not like computer. It's not just precise. We actually take into account so many factors that we don't even realize. So we probably, I'm not saying that we are judging the things wrong. I'm just saying that we probably want to be aware that we have a brain, a CPU that is not perfect. It's not like we're always making a perfect solution. We need to have a certain calibration in hand that could, make our thinking more robust, so we could adapt to our thinking patterns and know where we're good at in calculating risk and where we are bad at. And I mean, you would expect this to happen, on its own. Like I'm getting more experience in software engineering, and I'm trying to understand the systems better. I get more knowledge, and I'm becoming more smart, and this should happen like unconsciously. That's not the case, because we are not living in the same world every day. Like we switched a company, we switched a project, the project on the different stage of development. And the whole world of risk, the whole space of risk is different now. Like the startup is incredibly different from the legacy, and the risks are different, and the project goals are different, and the budget is different, and the team size is different, and amount of work is different. Like everything is different for the same project in the beginning and in the end. So if we are trying to just hope that our thinking is correct because we have like 10 years of experience, we are wrong. I know that because I have 10 or more years experience in software engineering, and I make mistakes every day. Like that's the reality of it. Like we can't make perfect decisions just because we have experience. That's how it works, unfortunately. So we have to do something different. Well, one thing that you want to be is you want to be realistic. You want to have a certain feedback about how your brain perceives risks and how it works, like how it thinks, how biased you are, like just by default. I see that a lot of decision making that is driving me or other developers is not about risk. In fact, it's just to show how smart you are. Like I see that 95% of time when developers talk about, oh, what if server will fail, or what if database will be inconsistent, they don't really care about the company or risk. What they want to do is to show how smart they are. They just want to raise their personal value in the conversations, just to show, I'm smart, I thought about this risk that this might happen, say hooray to me, I'm a hero. You would be, you're maybe laughing, but that's the reality. That's how developers are actually functioning. I mean, we're all people. That's our instinct to, care about our status in the community. And developers care about this. That's why developers always try to say smart things to care about their status. It's incredible, but that's what I often see, that a lot of technical decisions are made not only because that they are needed, or not only because business wants them, but also because the developers pursue their own personal gains, personal status gains. Another one, you need to understand that if you have a certain risk in your software or everywhere else, you don't want to cover it. You don't just to say, we need to reduce risk, or we need to do something about that. First thing, you need to accept it. You don't need to say, if we would have a server failure, like, let's make sure that our system is immune to server failures. That's the wrong way to do that, because nothing is immune to server failures. There will be a situation where more than half of your cluster dies and you would have a server failure. So you could reduce the risks, but the first thing, you need to accept it. You need to know what you're going to do if it happens. And then if you see that, we could fix the server failure, but it's going to be really costly to us, maybe we should reduce the risk. So first thing, you accept the situation, you know what you're going to do in this situation, and then you try to reduce it. You're not just going, trying to fix the problem right away. And you need to understand that it's impossible to prepare for something that you didn't already experience. For example, if you want to establish backups in case the database fails, if you didn't ever in your life saw how the database fails and how the data corruption looks, and you don't know how to restore the database after the failure, well, you cannot develop a backup strategy that's going to help in that situation, because you don't know even how it looks. So you probably want to simulate failures or ask other people who already had such failures on how they look. So then you could understand what is the situation you're trying to fix, and then apply a fix to it, because you don't want to fix something you don't even know that it exists or how it looks. You may think that, if a server fails in my head, and an autoscaling group is going to replace it. Maybe not. Maybe server fails in such a way that it always reports healthy to the load balancer, and it's just going to hang there and be irresponsive or work slow. There are many things that could go wrong, but you just planning for one thing because you just imagined a certain scenario in your head. So it's better not to imagine a scenario in your head, but be realistic and draw the common failure scenarios from the data, from the external world. And you need to be realistic that you're going to always do things wrong. You're not going to make it perfect. That's the reality of it. And I have also, I just show you a picture about this these biases for developers. When I bought new home, I decided that I will make a smart home Internet of Things setup here, so I could control light switches and other things. And I thought, it would be cool because I could control everything. I could control temperature at home. When I'm remotely at work, I could log into Wi-Fi and do something cool things. But then I just thought about this deeply and realized this is dumb. Like, why do I need to have a light switch controlled from the phone or from the, let's say, from the microphone, like, Alexa, turn off the light. This is just stupid. I could just turn off and turn on the light, like right here, incredibly fast, useful. I don't even need to speak anything, just one button and it's working. Like, it's just, I realize that the whole this smart home thing is just stupid. It has nothing to do with practical purposes. It's a way to show off how technologically advanced person you are, and it has nothing to do with actual practical application for your whole, for your own life. It's incredible how this bias thinking is embedded into us. So what are you gonna do about this? Well, the most practical thing related to risk is to just calculate it. Like, you have to put the situation on a paper. Yeah, you don't need to imagine, what if something fails? This is completely wrong. This is a totally misleading thinking, and it's totally misleading, especially if it's done like in a group. Like, if a team starts to discuss what we're gonna do if something goes wrong, it's just, if this conversation doesn't last like in 20 seconds, it just then goes to nowhere. First of all, you need to talk not about risks, but about possible solutions. So what you are going to do. You don't need to care about the risks. You need to care first about actions. What we're going to do. Are we going to do nothing? Are we going to do solution A or solution B or solution C, whatever? Like, you need to ask every team member not about what risks out there first. First, you need to ask them what we should do. What's your proposal in terms of us making an action? And you just write this in columns here. And then you could go forward with asking people, what are the possible risks we have that we want to mitigate using those actions. Here is an example about, a question: should we use backups or live replica database? So we could just make a backups, continuous backups or whatever, and we might have a live replica. Live replica is cooler because we could restore the data immediately, and we don't have like lost, we don't have, for example, a few hours of lost data. And we don't, if you will start to discuss this and you will, try to use some logic to say, what solution is better and what solution is worse, you will always end up in a situation where all these developers' biases of the whole team are gonna capture the conversation, and they're gonna lead it to a certain solution that satisfies their personal goals. Like, there is no guarantee that if just teams decides to create some solutions, that they will create something that benefits the project, the company, or something like that. We are selfish creatures, and most of the things people are just, for example, people are just used to a certain solution. They're just gonna push it for it. They think, I like live replicas, I'm going to push for this solution. People don't bother to explain on a paper why this is important. So That's why we have to build this table with possible solutions and all kinds of risks that could happen in these solutions. And then we have to, like in each cell, we have to calculate the amount of money lost for this combination. Like if we do nothing, the risk of data loss like is 5% per year. Like all the risks and all the solutions and all the remediation procedures here are calculated on annual basis. And if there is some capital investment associated here, you have to just amortize it on annual basis. So on average, every year I have a 5% chance, for example, of data loss if I do nothing. If I just have a server that has no backups, no replicas, that's it. And do nothing should be always your first column, because there are some cases where it makes sense just to do nothing and not invent some risk remediation strategies. So you just calculate how much it costs to do nothing. Like it costs $500,000 per year, for example. And then we just have a backups. The backups, they don't eliminate data loss 100%, because yes, you might implement the backups, but maybe they are misconfigured. Maybe somebody fucked something up and they are backing up the wrong thing in a wrong place in a wrong format, and the solution didn't work properly. So there is a chance for that. Or you made a backup, it's working, the data has been lost, you're trying to recover and you can't recover, or it's a backup is incompatible, or what. Some things may happen, and that's why no risk here, unless this is really technically impossible, is going to be zero. It's going to be reduced. So backups, they don't eliminate the risk of data loss, they just reduce it. And live replicas, they don't eliminate the risk, they reduce it to a certain value, but not completely. And same goes for other risks of outage. The backups, they don't, for example, don't affect the risk of outage, but if we have live replicas, we could switch over, so either the magnitude of outage is higher or the risk of outage is lower. However you like it. So there is a certain number, there is a certain cost, annual cost associated with each solution and each risk. And the amount of risks possible is just incredible. One thing to note here, like if you see the total cost of each solution, you could see that we have a lowest value for the backups, and you might think that, oh, this is the cheapest option in terms of the risk handling, but it's not the cheapest one. Like it has a lowest total cost, but it doesn't tell about the cost of implementation, because the cost of implementation is here. This is a total annualized cost for the company. So if this number is small, it doesn't mean it's cheap solution. It means it's a best solution, best cost to benefit ratio. And I've talked about different kinds of risks that we have. We might have a lot of risks here. One note here that this chart is not perfect. Before we just go into the specific risks that you might encounter, you need to understand that this is not a perfect solution. This table doesn't, it's not a silver bullet. It's going to have mistakes. It will have same biases that you had in your head, but in a table format. Like it doesn't solve the problem completely. It just reduces the impact of biases, and it allows to constructively collaborate on the risk management process. And you could share this table with business, to say that at that time we made this decision because of this table calculation. And you kind of move out the feelings out of the equation here, because you're not, yes, you use feelings to estimate the percentage of risk, the magnitude of risk, but you don't use feelings to calculate the sum of all risks, because we are very bad at it. We can estimate percentage, how often something happens. Yeah, we could look up on the internet, we could imagine a number, we could base it on our experience. Same goes for the magnitude of the risks. But, summing up the risks is not a human task. So, it's better to do it in a table. And the most important things is that, as I said, you will not make a perfect risk management strategy in your life. It's not possible, but you will make the best possible solution, the best possible decision at the time with the information you had. Like, it's not you're going to make it perfect, but you're going to make it as good as it was practically possible. Now going to the common risks that people just forget about. So we just, when we are outlining these risks in the table, you need to also think about, you have to think broader. Like, what other risks are possible here related to decision we're making right now? These are the common risks everyone forgets about. I call them meta risks because they kind of, just outside in a different dimension. That you have to take into account. You don't have to take into account all of them, but you just want to look at them and think if they're relevant to you or not, because it's just a matter of forgetting about some risk while doing the calculation. You just look through the list and you see, oh, it's not relevant, oh, this was important for me, so you could add it. And the rest, you just, you think it's not relevant, just toss it off. I will go through the whole list because this is very important, to explain each point. So first of all is a risk of risk remediation not to work. This is an example with the backups. We apply the backups to deal with the risk of data loss, but it may not work. So we have to take into account the success rate of the project we are executing to remediate the risk. Another one is increasing risk in other areas. If we're trying to eliminate a risk, for example, with introducing a live replica for the database, we're making a system more complex. Now, because we have a live replicas, the drivers on the software side, on the application side, have to be able to switch to a new replica if the switchover happens. So if that doesn't happen, well, we introduce new risk. If drivers connect to a wrong database, maybe there is a chance of data inconsistency. Another risk. So when we are implementing some solution to cope with one risk, we may inadvertently cause a risk increase in other areas. So we might actually introduce a new risk, because of our solution. And typically it's just, adding complexity to the project, which is always not good. Another thing is that you could, if you implement a perfect risk, a perfect solution to mitigate risk, you need to take into account that it may be so good that people just may forget that outage may happen. Like if you have some system that works 100% of the time reliable, when it doesn't work, people may be caught on guard. For example, people saying that car works all the time and it doesn't break. They ride into the desert, the environment changes, it's too hot, the car breaks. Now they are sitting in the desert and they don't know what to do because they didn't expect the car to fail because it was so reliable over the 10 years period and it didn't break. So, if something is too reliable, there is a risk of people to forget that, so you need to handle that situation. One of the most important risks, in fact, why we are doing the calculation is the risk of business being non-profitable, or the risk of a solution to be too much expensive. I would probably not tie this to cost, but rather to time. Like if you have a business and you have a startup and you're trying to build a new product and you think too much about implementation and not the idea, you think too much about infrastructure and not about clients, you could end up having your competitors just going past you and getting all the clients because you just wasted too much time developing solution, because there is an opportunity window and you missed it because you thought about which database you need to use, how good it should be, all the failure scenarios, and your competitor just set up an SQL database with ORM in PHP, and it's working and the clients are happy. And and they have to deal with the legacy, but it's not a problem because they already got the clients. And you did everything perfectly, you didn't got them because, well, you just missed an opportunity. So, concentrating on a technical part may be a way, may be dangerous. So, there is always a risk of business not, meeting its goals. So the business goals should be the first, should be more important to you than the, chances that a server will break or something like that. There are some risks that can't be put in a table. Like there are risks that could just bankrupt the company. For example, if you see there is a risk that somebody may break into your CI/CD pipeline and just delete the whole infrastructure with all servers, all the data, and take over your AWS account and do whatever they want, and you can't recover from that, well, that risk cannot be quantified. It's just total disaster. It's like calculating a cost of a moon falling onto the earth. You don't calculate it. You're just gonna destroy everything. That's the same example. So there are risks that you just have to eliminate 100%. You have to reduce them to incredibly low values, let's say. You don't have to calculate it. So you could essentially put some incredibly $1 trillion amount near them to properly, put them in this risk calculation table. Same goes to the risk of destroying people's lives. For example, if you're in a healthcare and there is a risk of your machine, hurting a human being, you don't want to put a $1 million value across a human life and then say, no problem, it's going to happen rarely, but you might actually be electrocuted. But this happens for 1 in a million patients, so not worry. It's the insurance is going to cover it. It's just wrong way of thinking. There are some risks that you just have to get rid of 100%, or your product is crap. There is also a risk in a situation change. As I said, as the project develops, as the time goes, the environment of the whole project changes too. The project, has a pivot in functionality, people lose motivation, somebody left the company, the market has changed, like AI emerging, or there is a buzz factor that a bus rides over some key employee and bam, it's a whole different situation here. So you need to account, the calculations that you are doing should not just account the current situation, but also should account, things that may change in the future, in near future, in a realistic scenario. So for example, we're doing this calculation, but what if the project going to pivot a bit? Is it still going to be more or less optimal solution, or is it just going to be, completely opposite of what we are trying to achieve? There is also risk to think that all the risks were handled. Like people think that if you have a database with live replica, it means it's 100% reliable, nothing's gonna work, nothing's gonna break, it's going to work perfectly, and we don't need to worry about this more, we have this handled. Or for example, we don't manage our infrastructure, we use cloud solutions, that's why we don't need to worry about infrastructure failures or network failures. No, it's not handled. Actually, it's the same server room, it's gonna fail the same way it's gonna fail in your, if it would be yours. It's just a difference who is gonna fix it, and how, that's the whole difference. But if you have your data center and cloud data center, they fail the same way. I mean, it's the same infrastructure. You didn't handle the risk, you just offloaded it. So there are many situations when people think that, we're gonna reduce the risk by, changing something, but in fact the risk wasn't reduced at all. There is also a risk that people overthink the risks. They try to, handle every type of risks. They have to handle server failures, network failures, database failures. What if somebody, some employee gonna leave? What if the project gonna pivot? What if? They have a lot of concerns, and they becoming so overwhelming that the whole process stops. So if you take too much risks into account, you're actually doing a counterproductive work. You're making situation worse. So there is a risk of handling too much risk. You have to hit a balance here. And of course, there is a risk of multiple things to go wrong together, like a perfect storm. If you have a failure, there is a high chance that it's not going to be alone. Like if you have a network failure, then you have a server failure, then you have a database failure, then you might have a data loss, and you may not log in to the network switch to switch over to some other data center. Many problems happen at the same time. Or for example, you have a political instability in the region. Well, you have no access to the data center, you have no electricity, you have nothing, it's just cut off from the whole world. You thought you might, if electricity would go down, we will just, run a generator. No, your generators are stolen, for example, or something like that. I mean, so there may be so many things go wrong, so the things, they tend to go wrong together. Like if you see people leaving the company, they typically leave company in batches, because one failure increases the probability of others. So that's why you need to think about these failures not as a one failure, but probably you want to take into account other failures too, like adjacent ones. I mean, it may sound too overwhelming. There are too many things I have to think about, with the risk management. You don't. The simplest possible strategy you might use to deal with this, if you don't want to calculate all the risk, if you don't have time for that, is just to make sure that you don't repeat the same mistake twice. Because if something has happened in the past, in the history of this company, in the history of this project, in the history of this application, there is incredibly high chance that it's going to happen again. For example, if the server has failed, it's going to fail again soon, because it's a signature that underlying infrastructure is crap, and the event itself increases the probability of failure of the future events. It sounds kind of paradoxical that a server failure increases the probability of other servers to fail, but that's my experience, that if something goes wrong in the application, there is a high chance it's just going to continue. If you have one SSL certificate expired, You might have other self-certificate expert, or it's a signature that there is a problem in a process managing the whole stuff that you have to deal with that. So if you have a problem, it's not just a problem, it's a signature that there is a problem in underlying solution. If you have one security issue, chances are you have a whole list of vulnerabilities on your platform. If you have a project that missed a deadline once, it's going to do it again. If there is a person that says, oh, I don't have money to pay you, I will pay you in future. No, he's not going to do that. If he didn't pay you once, there is an incredibly high chance that he's not going to pay you in future. So all these outages, all these problems, they have this repeatable component. So rather than to think about, oh, what if some server fails, if you never had experienced this on your project, you don't care about this because this event is so rare that, it just doesn't make sense to do that, because there are other outages that much more frequent than that has to be addressed, and you don't address them because you think about some future failures. That's the wrong way to do that. So the risk has to be handled based on how often it happens and its magnitude. If you see that it happens often and it disrupts the whole business, well, we have to address it soon. And the business people understand this pretty well because they're running business, but developers not always understand this. Sometimes they have a certain recurring problem and they say, oh no, yeah, we know about this problem, it happens all the time. No, it's not the right attitude. You have to fix it. And one thing to emphasize, I want to emphasize, is if we are talking about the risks, the infrastructure risks are the lowest probability ones. I understand that some companies may have 10,000 servers, and because of the number of servers, they fail every day. That's understandable. But if you just have if you're a developer and you work on one project and this project runs on 3 servers, there is a chance that the chance of the servers failing is just once in a decade. But the major contributor to the outages and risk is you, is a developer, because server runs pretty reliable. But people mess up things every day. We procrastinate. We try to invent some bicycles. We try to make everything perfect. We're trying to, think about security issues that we just imagined. We introduce some stupid bugs in the code. We create, crazy architectures and use some fancy new databases, message queues, whatever, or infrastructure setups. So, if you think about this, so all the risks that happen in the software, in the application, on the application side, are often created by developers and not by infrastructure, because the server just runs here and the network works here, and if it fails, well, it's just going to recover. But if you make a stupid architecture decision, it's not going to recover. It's going to be here for years to come. So if you want to think about the risk, you have to also take into account risks that you personally introduce into the organization, because these risks are much higher than the ones you're just thinking about, server fails or stuff like that. So wrapping this up, as I say, there is a lot of bias in the way we think about the risk. I know that because I have a lot of experience in developing applications, and I know that 90% of decisions that I made in the past, when I look back, I see that they were not driven by, objective risk management or calculations. They were driven by my bias to show off, or to look good, or to look smart, or to not deal with a problem, or to conserve energy and save it on some other task, or to make the life interesting for myself. Many things not related to actually providing what business wants or the company wants. So what I found out, that if I will try to just put these risks in a table, just myself take a piece of paper and put all the risks and calculate them and see how much each solution costs to the company, in my own estimation, I could compare that number to the ones I had in my head. And I could see that, I thought that this solution was the best one. But based on the calculation, based on the realities, I see that, for example, do nothing is the best solution. That's why everyone doesn't do anything, for example. So this is very important. Like, the risk doesn't have to be felt, it doesn't have to be imagined. You have to calculate it. That's the best way to manage it. That's the best way to communicate it. And that's the best way to make decisions on important projects. Like, if you have some personal projects, you don't care about the risk you want, you could think about everything. It's your project or a small project. You have you could put your artistic soul into position of power and try to create some crazy solutions and think about the problems and create something, be creative. But if you have some critical components and you are in a huge organization, and it's not just about you, but it's also about the business, it's about people and about their well-being, well, you probably want to not just feel it or be creative. You also want to be very practical and boring, and calculate this risk to make sure that what you're doing is improving people's lives and not hurting it. Well, thank you very much for listening to this episode. I hope it wasn't depressing and boring for you, and I hope it was insightful and interesting, because I was very excited where I saw this risk management diagram. It was a part of the business course. It's business people, they use this table all the time. That's how they actually calculating the risk. We developers, for some reason, we don't. So I decided to talk about this. So thank you so much for listening. See you in the future episodes. Bye.